Okay, we're ready to begin our tech talk today on unlocking the power of expressions in Siemens NX. Now, your questions will be answered live at the end, but please go ahead and enter them in the chat as they come up if you would prefer. Now, our presenter today is Bilal. He is located in our Cincinnati office. He is an NX CAD applications engineer, a University of Cincinnati Mechanical Engineering Technology graduate, recognized as the 2024 MET Graduate of the Year nominee. With expertise in manufacturing, design, performance, motorsport, and 3D printing, he is now focused on opportunities in CAD applications engineering. Welcome, Bilal. The Tech Talk is now yours.
Thank you very much, Vicky, and welcome everybody to my Tech Talk on expressions in NX. And the agenda for today, give me 1 second. There we go. The agenda for today is, well, what is an expression? Why would you use them? How to use them effectively? Where can you use them? And then we'll continue on with a live demo showing you guys a couple things that we go over. Now, what is an expression? Well, expressions in NX are essentially named variables that control model behavior. You can think of them kind of like an Excel cell for your 3D model. Once you assign a value or a relationship, that parameter can drive other dimensions. Now, what makes this powerful is that the expressions don't just stay in the sketch, they're global. So whether you're modeling a hole, a pocket, or even an assembly constraint, you can use and reuse expressions throughout. And so this will allow you to maintain a highly parametric and intelligent model that can adapt with minimal manual updates. And the formulae, they work very similar to how you would set up an Excel spreadsheet to do calculations. So you can see like width equals 2 and then the asterisk length, which is another variable that I have. And you can see on the bottom right, I have a photo, or on the right side, I have a photo of what expressions look like in NX. Now, why would you want to use expressions? Well, using expressions is all about working smarter. Instead of manually updating each feature when a change comes in, you define relationships up front. For example, you might say that a hole's depth should always be half the block height or the block thickness. With expressions, that link stays live. So if you change the block, the hole automatically updates. And this keeps your models consistent, reduces errors, and saves time. And when you're working in complex assemblies or even the reuse library, expressions make your parts scalable and adaptable without any extra effort. And you can also use expressions to drive part families or feature templates, and I'll show you an example of a feature template later on in the demo. Now, using expressions effectively isn't just about plugging in numbers, it's about thinking like an engineer. You always want to make sure that your expressions in a way you want to name your expressions in a way that tells you what they do. So this makes your model easier to read, easier to share, and easier to update later. Now, as a note, NX does not like spaces or alphanumeric characters in your expression names. So like no @ signs, no spaces, no, I don't know, weird looking characters. But you can use underscores like I did with the bracket underscore width. And if I were to do bracket space width, it would give me an alert that would say the name is invalid. You can also create master variables and essentially try to drive multiple features from a single master variable. That way, a change in width or thickness automatically flows throughout the model. Oftentimes, NX will label these as user-defined expressions since they may not be derived from a dimension in a sketch, since you would be creating this in the expressions table, and I'll go over that in a minute. Now, when your design becomes more complex, linking to a spreadsheet would actually give you a powerful external control over the model. So you can use Excel spreadsheets to then change dimensions or update your model as you see necessary. Or let's say if you're deriving a couple of data points from an Excel calculator or Excel spreadsheet, you can then use that very Excel spreadsheet to keep essentially a link between what it calculates or the values you put in and the values that show up in your model or the values that change in your model. And I'll show you how to do that. So essentially, the key is to think ahead. You need to think, how will the design need to adapt in the future? And expressions are tools for making that flexibility real. Now, one of the best things about NX is that expressions are not just limited to sketches. You can use them just about anywhere. In a sketch, but also for features, pattern spacing, hole placements, and even routing lengths. In assemblies, you can drive child components using top-level expressions, which is powerful for modular designs, and for even more advanced users, expressions can be linked to external spreadsheets, like I said, or even logical formulas. And this lets you build fully parametric intelligent models that adapt automatically to input changes or design rules. And we used a lot of these expressions on the formula team, and that's kind of how I got very close to them in a way of saying. Now, what is the expressions table? Well, by default, if you hover over any command in NX and you see a couple keyboard keys in brackets, that usually means that that's the shortcut for it. So the default shortcut for the expressions table is Control E. The expressions table is your master list of all the variables driving your design. It's like your parametric dashboard. From here, you can rename values, group related expressions, or even add new ones from scratch. And NX is smart enough to auto-detect units and even allows you to apply functions directly within the expressions, whether using simple math or complex if statements. Now, one of the most powerful tools is the find references command. This tells you exactly which features or dimensions are tied to each expression, so if something breaks and you want to understand the logic, you've got full visibility. And if you're working in teams and want to standardize designs, you can export this entire table or link it to a spreadsheet for reuse. Now, you will quickly realize that every command in NX creates expressions that you can quickly edit through the Details tab. Now, the Details dropdown is a great in-context tool that lets you see how features are driven without needing to open the expressions table. Just expand a feature in the part navigator and you'll see a list of its dimensions, many of which are linked to expressions. This is especially useful in larger models where you want to quickly confirm whether which variable is driving a certain depth or offset, and you can even edit this expression directly from here. It's also a good sanity check when reviewing other people's parts or troubleshooting a design that's behaving unexpectedly. The details view helps you reverse engineer the logic without opening 10 different dialogues and seeing what drives what. Now, I'm about to show you how it's done. Moving into our very first file right now, this is very simple. What I'm going to show you is how to create, I guess, essentially a simple block or how to turn on expressions in your sketcher. Now I've just created a simple box here. Going in, I see I've just got this one dimension. And well, if I were to click on it, right click on it, you have this down here, says add and remove expression. And once you click that, it then creates an expression. But what if you want to create expressions by default? Well, if I hit the D key, which is a shortcut to the rapid dimension dialog box, and if you guys can't see a dialog box or an information screen, please let me know. You have different driving methods here. You can either create reference dimensions or expressions. I like to keep this toggled on because usually when I'm, using complex sketches, I will use this expression to then create stuff. So I can then say this is length. And I hit the enter key and that inputs it, and I'll keep this as 100. And I hit the enter key. Now closing this out, we see that that's there. And let's say if I want to drive the width to be half of this length, I can absolutely do that. In fact, I'll just label it, or I can leave it the same. And then I will hit length. And then I can multiply it by either 0.5 or divide it by 2. And when I hit enter, we'll see that we have an expression created, or essentially an algebraic formula. Now, if I change this to 200, then we see it scales up, and my width is half of my length, regardless of what that length is. Pretty simple. Now, as I was mentioning, the Details tab, which is a very, very, very useful tool, at least one of my favorite, user interfaces in NX. And now, right now, I'm in my advanced roles. So this may look a little different to you, whether you're with Team Center or whether you have the beginner role set up. So I'm just going to quickly show you guys how to change your role to advanced. Down here in your resource bar, you can see your roles, go to content, and then you can set it to advanced. And right now, I already have it at advanced, so therefore my customizations may look slightly different than yours. Now, Down here in this Details tab, if I click on it, we see that right now there's nothing in there. But if I select a feature, we can see that the expressions I used are all here, and only my expressions. And if I just added a simple dimension, it's not going to show up here. Now, if I wanted to change this to, let's say, back to 100 and hit enter, we can see it automatically updates my model. Now, what if I use a feature like an extrusion function? Well, it's pretty simple there too. I can also input expressions here. So let's say if I wanted this to be twice the width, which would just be the same amount as the length, but we do as we please, as they say. So I'll say width, and then I'll multiply that by 2, similar to Excel. Now I could just leave it as this, or essentially just put in an expression, or I could even, well, I misspelled width, I could just say any number, let's say 30, right? And I can hit OK. Now, if I were to click on extrude, we can see that I see both of those, the start value and the end value, both available as expressions that I can change, and I can even change it here. And if I hit that, it recognizes width is already an expression, and if I had misspelt it, it would give me an alert saying, hey, we don't recognize this misspelled expression that you've put in. And now we can observe that the length of this is probably the same as the height of this. Now, moving onwards, I will show you guys well, this is what I call my simple cuboid. I have essentially just created a hole, and this is one of the photos or some things that might have seemed familiar to you if you paid close attention to the presentation. Now, I'm going to go over the expressions table, and the expressions table is in your Tools tab, and it's right here, and as you can see in brackets, we have Control E. So I'm going to hit Control E on my keyboard, and that'll open up an expressions table. And you're going to hear me say expressions and expression table a lot. Now over here, I have all of my expressions available to me in this model. Now I'm going to try and make this a little bit smaller and try and move this a little bit to the side so that you guys can see it. Now I'm just going to go over the expressions table and what you can do in it. Well, you can see a couple of the actions as you can create new expressions, and you don't necessarily need to hit all these buttons. You can oftentimes just do it by double-clicking an open box and then adding in your expressions. Now, doing something like that without having it referenced to anything will then create something called a user-defined expression, and I'll show you that in one of my next few models that I'm about to show you. But essentially, in the expressions table, you can create multiple interpart expressions, which will then link different models to each other, and I'll show you that in I believe my third or fourth model. But I'm just going over this dialog box, as I would like to call it. So you've got different settings. Now, if I am to change something, so let's say if I make this, let's make it 200. And if I hit enter, we'll notice that this changes because by default, this will remain on, your delay expression update. When I make a change, it'll show me everything that changes, and I'll highlight it a darker green if it's something I've directly changed, and a darker orange if I hit something, if I change something directly, and a softer orange or a lighter orange for things that are in relation to it. So you can see I have certain things. So these are all expressions named by NX itself, so therefore they don't have names, but you can see that if I change one thing, they're driven by each other, and that's why we see that change. Now, if I hit apply, you'll notice that that changes. Now, because, in fact, this is being driven by the hole, so if I click on this hole on my feature tree, we can see all the expressions that are driving it. Now, over here, you may notice that this might be the tip angle. If I wanted to change this, I absolutely can, but for the sake of this demonstration, I'm not going to because that is my standard drill, let's say. Now I'm going to go into my view, and I'm just going to edit my section just so that you can see that the hole width also changed from being to always remaining half of the thickness of this block. In fact, I'm going to just change it to absolute, and there we go. Now, if I were to change this back, this hole is not going to bust straight through my block. It's actually going to still remain half of my block thickness because that's how I set it. All right. And so that was a quick view of the details tab and a quick view of the expressions table. Now, as you saw me do with my details tab, you can do some more complex things. So here I have a sketch that drives this control arm. It's a very simple control arm. And of course, it's I wouldn't say it's made with great engineering judgment, but it's let's just say a proof of concept model. Now here I have two driving features. One is the total offset, so the length from this bearing cup all the way up to the other two, and the total angle between them, essentially the sweep angle. Now, I could essentially change it in here, or if I wanted to be much quicker and fancier, I can just click on this, having my details tab open, and then I can then change different values. Now, let's say if I wanted this to be a 90-degree sweep angle, I can do that. If I wanted to make this smaller to 200, I can absolutely do that too. And you may notice in my assembly over here, which uses these control arms, you'll see that if I save this, it'll save over there too. Or it will once I actually open up that assembly. Now I'm going to change this back to my 60 and 300. But it gives you a good idea or a good understanding of how you can use expressions. But let's say if I wanted to change, oh, that's my preview tab, not my details tab. If I wanted to change my external diameter of this bearing cup to, let's say, 50, well, I can do that too. And the way how I did that is just by smart modeling, or I guess smart sketching in this case, by taking expressions on this particular bearing cup over here and just setting equal parameters in my sketching or in my sketcher. And I can show you an example. This relation make equal to the rest of these bearing cups. And then I was able to extrude them, and you understand the drill. And I'll change this back to 30 because otherwise it looks weird. Now let's go to this suspension upright. This is a pretty simple thing. You can also have essentially different relations or even interpart links. And this is the point that I wanted to drive with this particular model. Now, let me open up my expressions table. In my expressions table, you can see I have all my expressions here, but I can also choose what I want. In this case, I have a user-defined expression. What is a user-defined expression? Well, I mentioned that if you were to do any master variables, such as, for example, this is one that I just created in NX. And if I were to just, say user exp and hit enter, not just because I'm doing it in my user-defined expressions, but just because let's say 600 over here. And if I hit apply, right, it creates a user-defined expression. Now, I just created this, but I haven't linked it to anything. If I were to go to my unused expressions, you'll see that this is there. So if, let's say, you create expressions, but you don't know where they went, or you don't know where they are, or even if they're being used, this is a useful way. And this essentially shows you the visibility of the different expressions. These are all the expressions I have. Here are the user-defined expressions, the ones that I've created myself and not linked to a sketch yet. And of course, if I wanted to delete something, it's very similar to Excel, where I can just select the role and delete it by right-clicking and then hitting delete on my dropdown. Now here we have named expressions. These are all the expressions I've named personally. And so rather than giving me all the expressions that I want to see, or all the expressions in this particular model that were created by all the features, I can just see all the ones that I created and I named. And so you can see wall thickness is over here. And if I were to create this, or sorry, change this to, let's say 100. In fact, no, 100 might be a little too much. Let's say 50, but before I do that, I'm going to move this over to this side. And I'm going to remove delay expression update. And this can be dangerous because let's say if you set a value to something that would either intersect lines or perhaps, make NX confused, you might break your model. But then again, a simple Control-Z or undo will fix your issue most of the time. So I'll say 75 here, and we should see that wall thickness. Well, of course, I broke my model as I was just saying that. Let's change that back to 25 then. There we go. So we can see that model changes. So the width of my wall from this bearing hub holder, essentially, or this bearing hub, I can then, well, I'll just show you guys pretty quick again, is that it changes pretty easy. I can also do different things, such as change my bearing cup size. Well, that's my bearing cup size. Is that bearing cup size or is that bearing cup height? Never mind. We're not going to change that. You can also see I have an expression that says don't touch this. Now, I could be cheeky as an engineer and of course disregard that. But let's say if I wanted to make sure that don't touch this doesn't show up, or at least has a visual way of saying, hey, don't actually touch this, I can go into my expressions table, right click on this expression and lock the formula. Now, when I hit apply, when I go back to my sketch, you can see I can't do anything with it until and unless, of course, I go in to my expressions, right click again, and then unlock it, or I can even override things as well. In fact, speaking of overriding, you see I have this interpart link over here, and I'm going to expand my table a little bit. And we can see my source column tells me where things are being called out, or at least what's driving them. In this case, I have a source, or this thing called control arm, column, and then internal diameter, or INTDIA. And over here, the formula says it's inner part. Well, it won't let me change it, but I absolutely can override it by right-clicking and then toggling the override lock. Now, let me show you what exactly is an inner part link. Now, I'll close this out. I'll go to my control arm, actually go over here, and you may, well, sorry, I didn't mean to double click. You may notice that INTDIA is this right here. I'm going to change this to 50. And I'm going to change this to, let's say, 40. Or actually, no, we'll change it to 30 just to make sure we don't break anything else. And so I've made that change. And you may notice that over here in my refined upright, these two holes that I'm driving with that inner part link have changed their size. And I can take out my measuring command in my analysis, measure, and then see that, like, okay, this radius is 15 millimeters. And this one, which was the original, not the entire thing, NX, just the one. Yeah, and the radius of this is 12.5, and I can, of course, change that to my diameter, which is 25, which it was originally. So that's how you can use inner part expressions to then drive things in other models. Now, let's go back to my expressions table. Very good. Yeah, I think this covers pretty much everything I wanted to show you guys. And yes, if, let's say, you see this inner part link and you want to see where you can go find them, you can oftentimes right-click, and this is where you can find different references and where they're used. Right-click your, let's say, the expression that you're trying to find and where it's being used, and go to List References. This will then open up a list of all the references where it's being used, and you can see, okay, the references in this part is mounting hole, or the hole 6 diameter, and of course that's driving another hole as well. Now, what if I were to go into the original, right, where I created that link? Go to my expressions table, and if I were to right click and hit list references, it should tell me that it's in another assembly as well. So it says, in this case, yeah, used by report for expression internal diameter equals 30, referenced or refined upright is the reference, where it's at, or what the name of that particular formula is, and of course the formula type, which is inner part in this situation. Pretty simple. And that's how you can kind of drive different things. Now, if you wanted to use expressions in your assemblies, well, if I open up my expressions table and move my little assembly over here, you may notice that I don't see anything, or at least nothing named. In fact, if I open up all expressions, all I see is the constraints that I set, the distance constraint that I set. Now, yes, can I change this? Absolutely, I can. However, what if I wanted to see something more like, well, this control arm? What if I wanted to change that? Well, if you have to make this your work part, and once you make it your work part, you'll then, of course, be able to access your feature tree and, of course, the rest of whatever you needed to see. Now here, I'll change my internal diameter back to 25, and we will change my external diameter back to 30 just to make it look normal again. And of course, if I were to remove this, it would immediately update. So in this case, I'm just going to hit apply, and apply keeps the expressions table open. OK, applies, and then closes it immediately. And so that's one quick way how you can do things, right? So I go back to work on my displayed assembly, and we'll notice that, yes, the holes still match because these control arms are driving the whole diameter of this upright. Now let's change something, sorry, not on the control arm, but let's change something on the refined upright. Let's say if I wanted this offset to be slightly different. Well, I can do that again, either in my details tab or in the expressions table. But let's say my steering arm offset, I want that to be 150 rather than 105. And of course, this isn't ready for the car yet, so it's a little chunky and definitely heavier than I would like it to be, but this gives you an example of how your models can change, assuming that you set them up correctly. And of course, if I wanted to change this, I can't, and it won't let me unless I do an override. You can now, on the topic of inner part expressions as well, you can, if I were to go back, feature expressions, all expressions, please. If I were to go here, I can lock updates. If I was playing around with my control arm, I can lock this, and it's not always going to change it. Let's say if this was a complex assembly and changing one of these small components, and we have several different instances of this component, and we want it to stop taking 16 business days for things to update, you can lock the update and then just make your changes, play around with it, and then of course once you unlock it, it'll then update. You can also toggle an interpart override lock as well. What that does is essentially you can now change it to whatever you want. In this case, I'm going to toggle it back off, and all is good. Now, let's talk about importing spreadsheets, or what you can do. Well, here I made a simple sketch. Right now I've made the sketch internal. If I wanted to make it external, I can, but I like to make it internal just because it saves a lot of space on my feature tree, and I can see what drives what. Now, here I have my expressions: bracket height equals 400, bracket length equals 300, and bracket thickness equals 50. Now, actually, one thing I forgot to do is to pull up my Excel table, so I'm going to do that really quickly. And here it is, my expressions example. And I'm just going to pull it over onto this other screen. There it is. So let's say I have my height, length, overall thickness, and the width, which is going to be my extrusion, all in this table. Now, how can I set this up properly? Well, it's pretty simple. You could do it from here, but I prefer to do it from the expressions table, and I'll tell you why. And it's actually a little, I would like to say, a cheeky trick of mine, or a cheeky tip. So I'll go into my expressions. Over here, we see nothing is driven by my external spreadsheets, and there's nothing that I can do about changing anything for external changes. But we have 400, 350, and 200. And on my Excel table, I have 500, 500, 25, and 200. Now, if I wanted to make this linked to an external spreadsheet, I can go in here, right-click where it edit, go to my functions. Now in here, you can see your most recently used, and you might be able to see what functions I've used. But here, you can actually create, all different types of functions. You've got absolute values. You've got trigonometry that you can use. You can use it to even ask you for names or numbers or strings, essentially, which is just words. And you can do so many different things all within NX. And of course, you can also have logic in here. Let's say you like to play around with your extrusions and your 3D printing apart. And you have your company logo that either you want to extrude it outwards or subtract it inwards. And oftentimes you do that just kind of whenever you want, or depending on what you're doing, or let's say you're still in the prototype phase, but every time you use your details tab and hit -10, it says, hey, I was an extrusion and a unite before. There's nothing to unite to anymore if I'm going negative, or at least I'm still in the body. So what's going on here? Well, you can, if that really annoys you, you can actually go into your expressions table and then change that Boolean function to a function like this, where it says, hey, if my value of this is less than 0, change to subtract, and if it's more than 0, change it to unite. So that's an example where you could use, or a very simple example of where you could use logic in your expressions. And that's some very advanced stuff if you're doing that. Now I'm going to go to my all functions and choose a category called spreadsheet. Now here I can then either have Excel read or whichever one is appropriate. In this case, I'll just say Excel read, and you can get a quick detail or a quick description of what each of these functions do. So if I go on to HLOOKUP, it tells me that the value from a given spreadsheet using a horizontal table lookup, and the target is a text string to match across a horizontal row of cells, and gives me a little bit more information. However, I want a number, so I'm going to choose UG Excel read. Now what that lets me do is I get to choose that, so I'll just hit or double click on it, and it'll then allow me what type of file system. Do I have an embedded file system or a native? And this is where, let's say if you have this spreadsheet on Teamcenter, this methodology may be different, but it'll be similar because from my understanding, Teamcenter, just like how our computers give it a file path, gives it an ID. So you might be able to then use that ID as your file path. Now I'm going to specify my spreadsheet. In this case, I have an Excel workbook. Let's say all files. There it is, my expressions example. I'm going to say I want that. And I know that from my expressions table, it's B1, B2, B3, B4. So I'll just say B1. And I'll hit OK or enter. In this case, I'll just hit OK. Now, this is my cheeky tip. Take this, Control A, which will select all of it, or, double click or triple click, and then copy it. And then once I hit OK or apply, right, it's now reading the new value. But now, rather than doing this long methodology for each of these, I can just hit, well, double click, Control V, go back a little bit, change that to B2, and then move onwards. And now double click, Control V, go back a little bit, change that to B3. Go over here, Control V, change this to B4. And you can see it's actively finding those new values. And once I hit apply, I have changed my bracket. Now, what if I change this? Well, oh, now clearly, absolutely, this should work, right? If I were to change this to 200, and let's say I wanted to keep this at 500, the thickness I wanted to keep the same, but let's say I wanted this to be 250. Right? So I've changed these values. Well, below, why hasn't it updated in NX? In fact, I've even saved this time, and it's still not updating NX. What do I do? Well, the answer is pretty simple. What you need to do is you need to update for external references. How do you do that? Well, there are several ways you can do that. One of them is by going to your menu, your tools, update, and then where is it? I lost it. Actually, it's in my presentation, so I'll just pull that back a little bit. There it is. Update for external change. Okay, I was right there. I just was looking for the icon rather than the actual name. So menu, tools, update, and then update for external change. Now I can do it this way, and once I click it, you'll see that it's going to quickly reread everything, assuming that you have your Excel sheet saved, because you have to save it. If you don't save it, it's not going to read it, or it's not going to be able to tell that you have made a change for sure. Now I've changed that. Now let's say if I were to go and make this back to 500, this looks a little too short, or, insert an excuse here. and I can say this is 50, and yeah, the rest of it looks fine, and I don't save it, right? And you can also, by the way, update for external references in your expressions table. So if I go to my expression table, I can also click this button, which is probably much quicker for you to do. But you'll notice, wait a second, nothing changed. Why did nothing change? Well, as I mentioned earlier, you got to save your expressions. You got to save your Excel sheet, sorry. So once I hit save, and then come back to my NX, update for external change, it then changes it. Now, I'll just hit no. Now, that being said, let's say if you have a more complicated assembly or a more complex assembly. Let's say if I'm trying to, like, what can I do with expressions, right? I want to be able to do some cool things. I said that you can do some automation with it. Well, here's an example of some automation, not all of it. But here's one example, which is a feature template. Now I'm going to use my reuse library, and in my reuse library, because let's say this is a standard part that my company creates, I go and I have created a feature template. What is it? We have a whole tech talk by Ryan Dillinger on this. In fact, I believe he posted it a couple months ago, and it's still pretty up to date. Well, it is up to date, and I would say it's good content if you want to try and do things like this. You can also use expressions for part families, which is where I think a lot of you may probably use them. So let's say you have a speaker cover for, let's say you make Bluetooth speakers, and you've just come out with a new model that is larger or even smaller. And one thing you guys are trying to experiment with is, let's say, the pattern and the hole size. Well, you can use part families to then automatically change that and very easily and efficiently change that. And part families will pull in all the attributes of your model into it that you can then change. Now, you do need to give it a name, and you do need to give it a part number. You can kind of give it whatever you want, but you still need, those are two values that must be in there. Now, moving back to my bracket template, let's say if I wanted to add a bracket over on one of these corners. So I can just drag this. This is my feature template. I'll choose two reference geometries. I'm just going to choose the same point. If it would let me. Okay, I guess I'll hide my part over here. Come on, let me hide it. Okay, it won't let me hide it. There we go. I'm going to choose this point over here. And let's say I want a 10 millimeter thick bracket. I want it to be 200 millimeters in length, 200 millimeters in height, and my bracket width to be 100 millimeters. And the way how I've set up this is that this rib, no matter how, and this pattern, no matter how I change it, they will adjust themselves to my bracket, no matter what I do. Now I can either click show result, or in this case, because I am confident in my feature template abilities, I'm just going to hit OK, and it'll create it right in front of you right then and there. Is that not pretty cool? I can already telepathically hear you guys say, yes, that is pretty cool. All right, and I think that is about it. That's all that I needed or wanted to show you guys for this tech talk. Thank you very much for joining me. If you have any questions, please feel free to ask them, or unmute yourself and ask them. Or if we have any questions in the chat, I will gladly love to know what they are.